Greetings to the stakeholders of MIT. It's Raghuveer Avankar here. Today I'm gonna having a small talk on nanomaterials and technology with you. Before starting this talk, let me tell you one thing that nanotechnology is not the modern technology. Yes, it is one of the ancient technologies. Thousands years ago, Chinese used gold nanoparticles as an inorganic dye into ceramic porcelains. In 1857, Faraday prepared gold colloids that was stable for almost a century before being destroyed during World War II. The Lycurgus cup is a 4th century Roman glass case cup made up of dichroic glass. Indians also made some one of the best use of nanotechnology in ancient times. The Bhasmas is also one of them. Charak Samhita is the oldest Ayurvedic epic in Indian cultural society used for treatment of diseased human beings. Concept of reduction in particle size of metals is clearly discussed in Charak Samhita. The word nano is derived from a Greek word nanos, which has meaning dwarf or small. Richard Feynman is the father of nanotechnology. Erich Düftler developed and popularized the concept of nanotechnology and founded the field of molecular nanotechnology. The man Norio Taniguchi was coined the term nanotechnology. So this was the nano history of nanotechnology. Let me visualize you the nanoscale comparison. Average height of a person is 180 cm, which is equal to 2 billion nanometer. Apple of 8 cm diameter, which is equal to 80 million nanometer. Diameter of DNA is equal to 2 nanometers. And hydrogen atom has the diameter of 0.1 nanometers. A nanometer is 1 billionth of a meter, means 1 nanometer is equal to 10 to the power minus 9 meter. So definition is, materials having their diameter in the of 1 to 100 nanometers are called as nanomaterials. The another definition for engineered nanomaterials is, engineered nanomaterials are chemical substances or materials that are engineered with particle sizes between 1 to 100 nanometers in at least one dimension. It is well established that engineered nanomaterials derive many functional advantages from their unique physical and chemical properties. There are various properties of nanomaterials, but we will focus only on basic properties included in our syllabus. We are going to see on the optical, mechanical, magnetic and chemical properties. As we come across nano size, some properties of nanomaterials get changed. Optical properties exhibited by nanomaterials are quite different from their bulk counterpart. This is mainly due to the effect of surface plasmon resonance. Nanomaterials also often possesses unexpected optical properties as they are small enough to confine their electrons and produce quantum effects. One example of this is that gold nanoparticles appear deep red to black in solution. After optical properties, come to the electrical properties. The spacing between energy levels and band gap increases with decreasing particle size. A modified electronic structure with wide and discrete band gap appears. The reduction of particle size into this range would result in an increased electrical resistivity. Nanoparticles show different mechanical properties relative to microparticles and bulk materials, providing more effective options for the surface modification of many devices in mechanical strength or to improve the quality of nanomanufacturing or nanofabrication, etc. To be more specific, on the one hand, the mechanical effects of nanoparticles can affect the tribiological properties of lubricants with nanoparticles as well as reinforced composite coatings. Nanoparticles are usually used as abrasives in nanopolish of ultra-smooth surfaces by chemical mechanical polishing (CMP), which is the most effective planarization tool in the manufacture of integrated circuits. Here it comes the magnetic properties. Magnetic nanoparticles are nanoparticles consist of magnetic elements such as iron, nickel, cobalt, chromium, manganese, gadolinium and their chemical compounds. Magnetic nanoparticles are supermagnetic because of their nanoscale size, offering great potentials in a variety of applications in their bare form or coated with a surface coating and functional groups chosen for specific uses. Especially, ferrite nanoparticles are the most explored magnetic nanoparticles, which can be greatly increased by clustering of a number of individual supermagnetic nanoparticles into clusters to form magnetic belts. Understanding the physiochemical properties of nanomaterials is essential in evaluating toxicological and ecological hazards. Nanomaterials can enhance the rate of reaction efficiently. In addition, information on the formulation and manufacture of materials is important in understanding its product variability, purity, performance, and use. It is important to chemically identify and characterize nanomaterials. Nanotechnology or nanotech is manipulation of matter on an atomic, molecular, or supramolecular scale. This design, characterization, production, and application of structures, devices, and systems by control manipulation of size and shape at the nanometer scale produces structures, devices, and systems with at least one novel or superior characteristics or property. There are tremendous applications of nanotechnology in the world since ancient times, but we are going to see only 8 basic applications which are included in our syllabus. We are going to see applications in computer chips, storage devices, catalysis, sensors, environment, space exploration, defense, and the last one in automobile. Let's see first application. Computer memory improvements with nanotechnology. Hard drives used as memory in computer consumes more power and has more chance of failure than solid state memory that doesn't have any moving parts. Nanotechnology is being used to improve the density of solid state computer memory. Devices such as computer hard disks function based on their ability to magnetize a small area of spinning disk to record information or establish nano applications. Disks and tapes containing engineered nanomaterials can store large amount of information. Future avenues for magnetic recording that will drastically increase the capability of data storage include spintronics and nanowires. Let's see nanotechnology in catalysis. Nanomaterials in chemical reaction can enhance the rate of reaction. Nanomaterials based catalysts are usually heterogeneous catalysts broken up into metal nanoparticles in order to enhance the catalytic process. Metal nanoparticles have high surface area which can increase the catalytic activity. Nanosensors are nanoscale devices that measure physical quantities and convert those quantities to signal that can be detected and analyzed. Sensors employ their sensitivity to the changes in various parameters they are designed to measure. The major parameters include electrical resistivity, chemical activity, magnetic permeability, thermal conductivity, and capacitance. All of these parameters depend greatly on the microstructure of the materials employed in the sensors. Nanotechnology is being used in several applications to improve the environment. Nanocrystalline materials possess extremely large grain boundaries relative to their grain size. Hence, nanomaterials are very active in terms of their chemical, physical, and mechanical properties. Nanotechnology could be applied to clean up existing pollution and to decrease to prevent its generation. Aerospace components with enhanced performance characteristics can be developed with nanomaterials. Long lasting satellites can be developed with nanomaterials. Also, more research on the future space man made missions is going on by using nanotechnology. Specially designed spacesuits made by nanomaterials are being developed worldwide. Nanotechnology holds strong promises for use in the defense industry. Nanotechnology can be used in two main ways by the soldiers. The first is miniaturization of existing equipment to allow it to be not only smaller but lighter, use less energy, and be more readily conceivable. The second is to develop and adapt new materials for military purposes. There are tremendous research and developments are going on the nanotechnology in defense sector. One of them designing lightweight and durable technologically superior exoskeletons for future soldiers. Nanodrones, bulletproof Kevlar jackets made by nanomaterials, etc. Let's see what are the applications of nanotechnology in automobile. Nanotechnology enhances the properties of materials and improves the performance of existing automobile technologies. Greater fuel efficiency can be achieved with nanomaterials. Let's see advantages of nanotechnology. Nanobots could be sent into a patient's arteries to clear away blockages. Surgeries could become much faster and more accurate. Using nanoparticles, we can create materials composed of very small size and with remarkable properties could pave the way for future techniques and superior products. Here it comes the disadvantages of nanotechnology. Atomic weapons can now be more accessible and made to be more powerful and more destructive. Products made with nanotechnology are more expensive and difficult for production.